Okay, looking at example 3 here, evaluating a trigonometric function at a given point. So the idea here is when we put an angle in standard position and we got this angle opening up to a certain degree, okay, and we have this point right here. Well, this angle right here that we can create, basically from the x-axis here, we can create a 90-degree right triangle. So just like before, the angle of reference that I'm going to actually be referencing here is actually right here is the angle that I'm going to reference. So if I'm referencing that angle across from the 90's hypotenuse, so that is just labeled R, or it's the hypotenuse, same as before in the last example. Across from this angle of reference is our y value, but that would also be the opposite. And R is the hypotenuse. And then adjacent to it would be the x coordinate, right? So every point that we're given, the x is just the adjacent and the y is just the opposite side, and our r is just the hypotenuse. So when we say sine of theta is y over r, well, that's the same thing as opposite over hypotenuse. So we're just solving the same problem as before when we're given cosine of a equals 9 over 13, or adjacent over hypotenuse. But this time, instead of adjacent hypotenuse, we're just given a point with an x and a y. So a lot of times when you're given the point, of course, you don't have the r, but we can find r by taking the square root of the sum of x squared and y squared. So here I have my x, here I have my y, so I just square those. And whenever you square a number, right, a real number, you're just going to get a positive, right? So it's 16 plus 36, and then I'm going to add those together, and then I'm going to square root. So I get 2 root 13. So then there's my r, here's my x, and here's my y. Well, those are the same thing as adjacent, opposite, and hypotenuse. So when I do sine, I'm doing opposite over hypotenuse, but it's really just y over r. So sine of theta equals y over r, and then I can rationalize that. 4 divided by 2 is just going to be 2, so I get 2 root 13 over 13. And then cosecant of theta would just be 4 over 2 is just 2, right? So it'd be root 13 over 2. And then cosine of our angle is just x over r, because it is adjacent over hypotenuse. So adjacent over hypotenuse, or x over r, so that'd be negative 6 over 2 root 13. Negative 6 divided by 2 is negative 3, so we get negative 3 root 13 if I rationalize it over 13. And then secant, the reciprocal of that, would just be negative, and you can put that negative on top, bottom, or to the side, just not both, right? So negative, again, negative 6 divided by 2 is 3, so that negative 3 would go on bottom, and then root 13 would go on top. And then lastly, the tangent, tan of theta equals opposite over adjacent, or since we're on a standard position here, it is y over x. So y over x, and then cotangent would be the reciprocal, and that is negative 6 over 4. So those are all 6 trig functions. So it's really the same thing as before, except for your y is opposite, your adjacent is x, and your hypotenuse is r. Because any triangle, if I have an angle that opens up in the first quadrant, and here's my point, or I have a point and I graph it, then I can just make a triangle right here. There's my right triangle. This would be my theta. I can do the same thing. If I have a point over here, my angle opening up of reference would be right here, and there's my right triangle. Same thing what I just did down there. If I have a point somewhere down here, then here's my radius, my hypotenuse, and I can draw a right triangle. My y is my opposite, r is the hypotenuse, and x is the adjacent side. So it's the same thing as before on example 2.